Now in this video I'm going to show you how to make this little waveguide cantenna with a main driven element upgrade over the monopole version, and this packs a lot of punch. This is a lot smaller than the traditional cantennas that I sell on eBay and I've shown you how to make many times before with the monopole element, but because we've got a upgrade on the main driven element here, this packs the same punch as the much longer version. So although it's a lot smaller, it's compact and it really does perform well. So we're going to go over how I make this. I mean, you can do a few changes if you want to the construction methods that I'm going to show you, but the measurements you really have to stick to. If you go outside of the measurements in any way, it will drift from its center frequency and it won't work too well. But basically it's pretty simple to make, and you know, there's only a few components. So let's get on and I'll show you how to put one of these together. So components you're going to need some kind of tubing. This can be aluminium because I'm not going to solder to it. This is 1.5mm thick, wall thick aluminium tubing I picked up off eBay. I buy it by the meter and it's around £30 and free delivery. We're going to need a length of this, and the diameter of this, the internal diameter, which is the important diameter, is 76mm, and as for the length, this is just shy of 135mm long. You want to keep it at one wavelength at 2.4 gigahertz, so you want something with a minimum of 126mm long and no more than 136, 137mm long. So you've got that small window to play with length, but no less and no more than that. So this is 135mm long. Now you're going to need to be able to block one end of the waveguide off, and we need a back reflector, and this is the back reflector for this tubing. I've cut this out using a hole saw, and this is some I think it's 1mm thick aluminium sheet that I've got, and basically there's a couple of different methods that I want to show you for connecting the back reflector to the tubing. Now the simplest method is to glue it on with some super glue. This one has been glued on with super glue. You don't get a completely clean connection with the super glue, so this is electrically connected to the tubing. It doesn't insulate it totally, but basically what I did is put some super glue around the top here, then I placed the back reflector on, then tipped it upside down, and I just drizzled some more super glue on the inside and just let that set with some activator. That is really strong, but it probably will fail eventually, and I would only do this if I wanted to make one for myself, and then I wouldn't mind if the back reflector came away and I had to repair it. Another method of connecting this up is to get a hole saw slightly smaller. This is a diameter piece here that is 76mm, the same internal diameter as the tubing, and you can see it fits quite snugly in there, and it also makes contact with the side walls, but at the moment it's not very strong. So what I've done with this one is placed it on the inside here, and then I've put some silicone sealant on the outside here. As you can see, there's just a little bit of a lip of around 4mm there. Silicone sealant to hold it in place here, and I also silicone sealed it on the inside as well. So that is now nice and strong, and also it's waterproof and makes good electrical contact with the tubing itself. Now the method that I'm going to show you in this video, I've got a diameter here of 80mm, and I've also cut off a small ring of the aluminium tubing here, cut a small section out, so now it will just about fit on the inside of the tubing, and I'm going to attach it to super glue it on to the back reflector here to make a little cap that will go over the top there, and we can add a little bit of super glue to hold this in place, but this is going to be a lot stronger than, let's say, this. And it also gives me the option of being able to pry this off as well and do any repairs if we need to be. So I'm not going to be using too much super glue to attach it to the back reflector. The little ring that I've got here making a little cap is going to do most of the holding in place, so we don't have to use too much super glue for that, and hopefully it should make it a little bit more, well, basically we can work on it and do any repairs if we need to. So that's the method that I'm going to be showing you in this video, but these methods are also just as good. That's super glued on there. You'll be surprised how well super glue connects two pieces of aluminium together. And then there's this one here where you have the smaller back reflector in there and then hold it with some silicone. I mean, this one is a nice method as well. Now, all the things we're going to need a nut and bolt to hold our main driven element in place. This is M6 threaded nut here that just fits nicely into the hole that is left behind with the drill on the hole saw. So that's why I've chosen this diameter. If you've got a different method of cutting these out, then yeah, go ahead and you can choose a smaller diameter threaded bolt here to hold it all together. That really doesn't make a great deal of difference to the overall performance of the antenna. But we also need a connector for this. Now I'm going to use a N-type connector for this particular one. I've used an N-type connector there as well, different mount there onto the chassis. This one is just going to need a hole drilling through. I've also got some here with SMA connectors in place, so really that's just up to you. I've also got a piece of aluminium here. This is 1.5 millimeters thick. That is going to be for our main driven element, and the measurements for this are 39.8 millimeters by 20.6 millimeters, and you really do have to stick to those measurements as well. There will be a PDF in the description for you to download, but being really super accurate and taking your time with the measurements, you really need to with this particular design, because small differences can make a big differences to the center frequency of this particular antenna. Now, as for the distance from the back reflector to the main driven element there, that needs to be 14.5 millimeters away. So what I've got here is some cork supports. I'm going to be using those to position the back reflector in place when we're ready, and that'll give us that 14.5 millimeter distance, and that is also very, very important. A half millimeter difference, if you get it measured at 14, will make a big difference to the performance of this antenna and shift its center frequency also. So 14.5 millimeters. You can use nuts to get that separation there, but I just find it a lot more easy as well if I stick these onto the main driven element, and then I can pop this in place and I don't have to worry because the cork is doing the spacing for me. Now, first job, I've got my main driven element here. It's already been measured off and cut to the exact measurements there, 39.8 millimeters by 20.6 millimeters, and the first thing I'm going to do is find the center of this and then drill a 6 millimeter hole through the center. I'm just going to measure from the diagonals to do that and then drill the hole. Now, once you've got your hole driven in the center, we're going to make a mark for the hole for the connection of the main driven element for the center of our N-type connector here, and I'm going to be using this wire, which is 1.5 millimeters in diameter. I'm going to solder that onto the pin like so, and then this wire is going to come through the hole and make a nice tight connection to the main driven element, because obviously we can't solder to this, so it's going to be a dry connection, which is perfectly fine by the way. And I'm going to be measuring up 4 millimeters from the bottom of our main driven element here. So I'm just going to put a little mark. I'm going to draw a line across there and then find the center and then drill a hole 1.5 millimeters so we can fit our connection through our brass rod here. I've also connected these up with using some brass tubing, but I haven't gone for a bigger diameter than 2mm. So if you want to use brass tubing, stick to 2mm and below, don't go over 2mm. As you can see from this one, we've got some brass tubing going through there. If it protrudes a little bit as well, that doesn't make any difference either, but you just want, when you're drilling your hole, to make a nice tight connection, because it is going to be a dry connection because we can't solder to it. Now I've got the hole drilled in there for the connection for the main driven element here. I've also gone ahead and soldered some of the brass wire onto the N-type connector. I've got an excess at the minute, we can always trim that down later. It's always better to have too much than too little. And now we've got the hole drilled in there. It is a tight fit with this brass wire onto there, and you can also put a little bit of solder on the top here when we've got that trimmed down as well, if you wanted to do that, just to get a really good connection with the aluminium. But I tend to find that this fitting in here with friction is more than enough to do the job. Now what I'm going to do is take my main driven element here where we've drilled the holes in place. I'm going to put that over the hole and line everything up, and then use the little hole that we drilled here to connect to the N-type connector as a little pilot hole. I'm going to drill through a little pilot hole in here, then make it the correct diameter to fit the N-type connector through. If we use this as the little template, so to speak, everything just lines up perfectly then. Now what I'm hoping to achieve here is to just tack this ring in place and then drizzle super glue in between the two surfaces, and then use the activator to set it. Hopefully we'll get this set in place. So I'm just going to put a couple of blobs just to hold it in place. Get a little bit of activator. And because I did that on camera, I haven't got it quite centered, so I'm just going to separate the two and center it off camera. Now that's better, that's nice and centered. So now I'm going to drizzle the super glue all the way around. Just let it work its way in. And popping everything together, I think I've kind of miscalculated a little bit. It was fine for the other connectors, but for this particular type, I'm going to have to change the position of these spacers, I think. So this is the main part of the antenna all put together. You can see quite a neat little job. Cut away all the excess from the threads and the feed line there. You could put a blob of solder on the top of that feed line, but really there's no real necessity to do so. It is making a good electrical contact there. So we've got this in place now. It's in there, it's nice and firm. It's also, I've checked continuity, it's making an electrical connection with the tube itself, which is what you really want for this to perform well. Now I'm going to use these little L-shaped brackets you've seen me use before on the channel, so we can have a mount in place for a tripod. So basically we just threaded it out there to the correct size for a tripod mount, and we've got these two riveted on here and a rivet through the middle there, and that gives you a nice place to mount onto a tripod. So I'm going to do the same with this one. And now that we've got the tripod mount fitted in place, riveted in there, I'm going to close off the end with some cork. It just stops any debris or dust getting inside, and it finishes it off nicely. Cork is a really good thing to use. It's got a low dielectric constant, and it's virtually waterproof without much effort, so it's good for mounting outside. So a little bit of epoxy on the inside and just leave it upright like that for the epoxy to run down, and then everything to glue in place. And then we trim this off and paint it with some black paint. Black's my favourite colour. Here we are over on the test bench then. I've got it set up on the bench, as you can see here, connected up in the usual way that you've seen in previous videos, and we're now looking at the output on the network analyzer. So we're scanning from 1800 megahertz over here all the way up to 3 gigahertz over here. I've got it centered, the cursor centered on this dip here, and that's at 2.45 gigahertz. Really nice dip. Not quite as wide as I'd have hoped, but you know, still plenty wide enough for what we want to do, because you have to remember that a waveguide like this, a cantenna, is also a very good band stop or band pass filter. Any wave that's too big to fit in obviously will not fit in the waveguide, and any wave that is lower than the cutoff point for a waveguide, if it's too small, there's going to be no guiding of that wave. It's going to bounce around inside, crashing into each other in a destructive manner, causing all kind of little blips and things that you would see on here on the network analyzer, a little bit like the output from the waveguide I showed you in the other video that I'm still working on, the Yagi waveguide. So you'd get a lot of interference, a lot of destructive combination of waves coming together, not really guiding it onto the driven element in the waveguide. So they are effective band stop or band pass filters, let's say, and that's why this kind of thing would be no good for the cellular networks. I mean, I could build one for say 4G around 2.7 gigahertz there, but you would only be able to pick up that frequency. There'd be no picking up frequencies lower than that at 2 gigahertz, 1800 megahertz, or even 900 megahertz. It just wouldn't be possible. So I don't think this kind of antenna would benefit the cellular networks, but you know, if you wanted to just stick at that one frequency at 4G to 2.7 gigahertz or even the 5G, and didn't mind if it drops out from time to time, then yes, you could hook one of these up to a satellite dish and it would perform really well. But apart from that, you know, I like to use them for Wi-Fi. This is a really good antenna, and I'm really pleased how this has turned out, but it's taken a lot of work to get there. So I think you'd agree it looks really nice over on the network analyzer. I'm really pleased with this. As I said previous, I will do a separate video with a speed test comparing this to the normal cantenna that I sell with a monopole. I also want to do that because I also want to compare the Yagi waveguide that I'm currently working on at the moment. As I said in the past, with the Yagi waveguide, if there's no real benefit, at least a dB 0.5 gain on a normal cantenna, I really don't see the benefit of putting all that extra work into making one. But I've got my fingers crossed with this particular design, so that's something to look forward to. But I will do a speed test with this to show you a real world test. As I said, fitting this part on here, if you didn't want to go to the effort of cutting out a small ring like I did, this does suffice. I mean, it's still on there. I've had this knocking around the bench for a few weeks now, and it's still connected there. Super glue really does do a good job at gluing aluminium. I think it's all the dust and everything that aluminium creates. It just has a really good connection there. But as I said previously, these are some that I've made. I think I've made 6 of these. I'll put them on the eBay store. Not something I'm going to make regularly like the normal cantenna, because it's cost of the aluminium tubing and time making these. It takes me a lot longer to make these than it does the normal cantennas. But I'll put some of these on the shop on eBay, so you can check them out if you so wish. But as I've shown, you You can do everything with a Dremel really. You don't need a bandsaw or anything like that if you want to take your time, especially if you can get hold of some of this aluminium tubing free of charge. Then yeah, it's a really nice build. But to finish off the video, the only consideration that I would give to this is you've really got to stick to those measurements. As I mentioned, there will be a PDF in the description for you to download, but as I said, I can't stress enough, you do have to stick to the measurements. A small deviation makes a huge change with this antenna, which is why I scratched my head designing this for so long. So if you did enjoy the video, please give it a thumbs up. Comments or questions, drop them below and I will do my best to answer them. Link in the description for the PDF, and if you want to purchase one of these from eBay, you know, you're more than welcome. And yeah, any comments you've got to how we could improve this maybe, then please, yeah, let us know again down below, and hopefully you'll join me on the next one.